This is the title of the quiz, focusing on the LedoitWolf covariance estimator. It's a method used in statistics to estimate the covariance matrix, which shows how different variables change together. The quiz will test your understanding of this method's properties. This is the main question for the quiz. We're asked to identify which statements about the LedoitWolf estimator in the Sklearn library are correct. Sklearn is a popular Python library for machine learning. I'm checking if you know that the LedoitWolf method is a type of shrinkage estimator. Shrinkage estimators work by combining the sample covariance matrix, a direct calculation from your data, with another matrix, often a simpler one. This helps improve the accuracy of the estimate, especially when you have many variables but few data points. I'm asking if you understand that LedoitWolf ensures that the resulting covariance matrix is positive semi-definite. This is important because a covariance matrix must be positive semi-definite to be mathematically valid. This property is not always guaranteed by a standard calculation. I'm checking if you know about the computational cost. LedoitWolf involves more calculations than just computing the sample covariance matrix directly. It's a trade-off. We get more reliable results but at the cost of increased computation time. I'm asking about the influence of data characteristics. The performance of the LedoitWolf estimator actually does depend on the number of samples and variables. That's the whole point. It improves estimates when there are limited samples compared to the number of variables. This is simply the space provided for you to write your answers to the multiple-choice questions. I hope you've grasped the concepts well. This is a quiz testing your knowledge of the LedoitWolf covariance estimator. We'll look at several statements and decide if they're true or false. This question asks you to identify correct facts about the LedoitWolf estimator, a method used in statistics to estimate covariance matrices. Covariance matrices describe how different variables in a dataset change together. The statement is true. The LedoitWolf method is a type of shrinkage estimator. What this means is that instead of directly calculating the covariance from the data, it combines the sample covariance with a more stable target matrix. Think of it like averaging your initial estimate with something more reliable. This is also true. A positive semi-definite matrix is a requirement for a valid covariance matrix. The regular way of calculating covariance doesn't always give you a valid result, especially when you have many variables and few data points. LedoitWolf cleverly avoids this problem, guaranteeing you a valid covariance estimate. Yes, this statement is true. Because LedoitWolf involves extra steps of calculating the sample covariance and then applying shrinkage corrections, it takes more computer time than just calculating the sample covariance directly. It's a trade-off. Better accuracy comes at a cost. I found this statement false. The whole point of LedoitWolf is to improve performance when the number of variables is large compared to the number of data points. Its performance is directly affected by the sample size and the dimensionality. This question tests your knowledge of the LedoitWolf estimator, a special tool used for estimating relationships between variables in data, especially when you have lots of variables but only a little data. We will check which statements accurately describe it. The LedoitWolf estimator is a shrinkage estimator. That means it doesn't just use the raw data to make its estimate, but it combines that raw data with a simpler, more stable estimate. It's like taking a weighted average to get a more reliable answer. Imagine averaging your raw exam scores with the class average. That way you get a smoother score. The LedoitWolf method is really good at making sure its estimate is mathematically valid. Covariance matrices have to be positive semi-definite. This is a mathematical property. In simple terms, it means the variance of each variable is non-negative. The sample covariance matrix often fails this when dealing with lots of variables and a small number of samples. LedoitWolf solves this problem. I want to be upfront. While it's better than a simple sample covariance, LedoitWolf takes a little more time to compute. It's a trade-off, extra time for a more reliable estimate. This statement is false. It's the opposite. The whole point of LedoitWolf is to handle situations where you have a small number of samples and many variables. Its performance directly depends on those factors. This instruction tells you to select every statement from options A, B, C, D that you determined is true based on your knowledge of the LedoitWolf estimator. This question asks you to identify the correct statements describing the LedoitWolf covariance estimator, a technique used to estimate covariance matrices, especially useful when you have lots of variables but limited data points. Think of it like this. You're trying to understand how different things are related, but you don't have a lot of information to go on. LedoitWolf helps you make a better guess. That's absolutely right. LedoitWolf is a shrinkage estimator, meaning it doesn't just use the simple sample covariance. Instead, it pulls or shrinks the results toward a more stable target, making it less sensitive to random noise that can mess up your estimations, especially when dealing with high dimensions and few data samples. It's like taking a step back to get a clearer picture. Yes, a positive semi-definite matrix is crucial because it guarantees that the variances, which represent how spread out your data is for each variable, are always non-negative, which makes perfect mathematical sense. The regular sample covariance might fail at this with a small dataset and lots of variables, but LedoitWolf cleverly prevents this problem. You got it, because it's doing extra work, the shrinking part. It takes more computing power than simply calculating the sample covariance. It's a trade-off between accuracy and speed. We accept a bit more computation time for greater reliability. This is incorrect. The whole point of LedoitWolf is to improve estimations when you don't have many samples and do have a lot of variables. Its performance is directly affected by both. The more data you have, the less the shrinkage matters. LedoitWolf is designed to help precisely in the scenarios where these factors negatively impact other estimation methods. This quiz question tests your knowledge of the LedoitWolf covariance estimator. We'll explore whether statements about its properties are true or false. I find this statement true. The LedoitWolf method cleverly avoids a common problem with sample covariance matrices. When you have many variables and few samples, the sample covariance matrix can become non-positive semi-definite, which is not mathematically valid for a covariance matrix. LedoitWolf solves that issue. I agree, this is also true. The LedoitWolf estimator doesn't just compute the sample covariance, it then adds a shrinkage step to improve the estimate. That extra step takes additional computation time. Think of it like this. Making a simple cake is quicker than making a fancy layered cake with frosting. I've observed this to be true. LedoitWolf uses shrinkage, meaning it takes the standard sample covariance and shrinks it, closer to another, more stable matrix, like a scaled identity matrix. This helps avoid unreliable estimates when dealing with high dimensions and few data points. I must say this is false. The entire point of LedoitWolf is to improve performance in situations with many dimensions and few samples. Its performance is absolutely dependent on these factors. It's designed to handle just those tricky scenarios. This is the title of the quiz. It tells us what we'll be learning about: the LedoitWolf estimator, a special way to calculate covariance. Covariance shows how much two things change together. This is the core question of the quiz. We need to identify which statements correctly describe the properties of the LedoitWolf estimator within the Sklearn library. Statement A says that the LedoitWolf method is a shrinkage estimator. This means it doesn't just use the data directly. It combines it with a simplified version, which makes the results more reliable. When dealing with limited data, I think of it as taking a step back and getting a better, more general view. Statement B says that LedoitWolf always produces a positive semi-definite matrix. A positive semi-definite matrix is a must-have for a valid covariance matrix. It ensures that all variances are non-negative. In simpler terms, it prevents illogical results, like negative uncertainty. Statement C says that using LedoitWolf takes more computer processing power than a simple calculation from the data. The extra calculations make the results more accurate, but this comes at the cost of more computation time. I would think of it as trading time for better quality. Statement D claims that the accuracy of LedoitWolf does not depend on how much data we use or how many variables we are tracking. This is incorrect. LedoitWolf is specifically designed to handle situations with limited data and many variables, so its performance is directly related to these factors. The instruction to choose all statements that are true. This is common in multiple-choice questions where several options may be correct. The button to submit the answers.